Good evening, all of you. Our next speaker, Dr. Anil Kumar Sharma, sir. It's honor for us that he accept our proposal to deliver a lecture. Presently, he is working in NIT Patna in the Department of Civil Engineering, and his basic qualification is he did his PhD in geotechnical line in Indian Institute of Science, Bangalore. That is Bangalore IA, Indian Institute of Science, Bangalore in 2015, and his BTech in Civil Engineering from Cochin University of Science and Technology, Cochin. So both his qualification is from a Class A institution. It's honor for us, sir, also. And his work experience is in 2014 he joined Indian Institute of Science, Bangalore as Junior Research Associate, followed with February 15, 2015 to December 2015, he worked as Assistant Professor in Shiksha Anusandhan, Bhubaneswar. Then from January 16 to July 19, he was working as Amrita Vishwa Vidyapeeth, Coimbatore, as Assistant Professor, Senior Grade. Then from July 19 to February 20, he is Assistant Professor Grade 1 in National Institute Construction Management and Research, Hyderabad. And then he joined in February 2020 in NIT Patna. He has many publications, reputed publications in journal, nearly, I think, 37, 38 journal or reputed publications is there. And his book chapter, National Conference, if it will conclude it, it will be nearly one quarter, 22, 25, it should be. And along with that, he is handling SERB sponsored project. Topic is application of microbial induced calcite precipitation MICP in stabilizing coal ash, and duration is 2.5 year and total budget is 21.68 lakh. And he received many awards. Few of them are like he received DST served International Travel Support Award for attending GEO conference during March 2029 in USA. Then second is Southeastern University Travel Grant for attending SEU Symposium of recent development in geotechniques during 8 to 9 July 2017 in China. Then third, his award is ISSMGE Foundation Award for attending geotechnical meeting during 25th to 28th May in 2016 in Iceland. And then MHRD scholarship for pursuing PhD in IISc Bangalore from 2009 to 2015. These are the few things that I just studied about Anil sir. Because if I'll just explain his resume complete, it will take another half an hour. So with this, I'm giving it's honor for all of us to hear Anil sir. Anil sir, followed. Please continue. Sir, you are muted, sir, I think.
Hello, hello. Am I audible?
Yes, sir.
Okay, okay, okay. Thank you for the confirmation. So I hope my PPT is visible to everyone.
Yes, sir.
Okay, okay. Thank you. And you are all listening to me clearly, very loud and clear.
Yes, sir.
Okay, okay. Okay. So the today's topic is okay. First of all, I'd like to thank the Department of Civil Engineering, GC Buxar, for giving me this opportunity to give a talk on ATAL FTP. And I'm very glad, Professor Anjani and Dr. Jitendra, for inviting me and giving me opportunity. Thank you very much. So without further delay, I will start my topic. And today's topic, I will briefly discuss about, the recent studies that I have carried out in. Basically, my research area is focused on green construction methods and something related to, we go for sustainable construction materials, in particular to uh, soil stabilization, and trying to find a way so that we
सर
can
जॉब
completely.
नहीं कुछ सर
Hello.
सप्ताह में
Hello. So I am just trying to find ways through which we can reduce the amount of cement or lime or any other materials which are, you are associated with greenhouse gas emissions. So mostly focused on sustainability in construction. So today, the topic is improvement in the properties of geomaterials using eco-friendly methods. So before going forward, I would like to highlight one important fact that a very important quote by John and Jordan, who has told that if we do any research and trying to develop a new building material, and particularly using that waste as a raw material, it's not a very simple task. It's a complex and multidisciplinary task which has got very technical, environmental, financial, marketing, legal, and social aspects. So this is very important when we try to do research on anything material which is particularly based on waste as a raw material, like fly ash, GGBS, or silica fume, so and so. So now, starting with the introduction, we know that I'm particularly focused on geotechnical engineering, so most of the examples will come from that area. So geotechnical engineering, basically, very resource intensive department, where the construction leads to lot of usage of lot of materials. For example, if you are going for the embankment construction, or the subgrade, or the uh, subgrade or subbase layers and all, we need large amount of materials, mostly the locally available soil or sand or aggregates or whatsoever. So it is a resource intensive department, and um, we use quite lot of materials, and mostly the natural. We are dependent on the natural materials, and my focus will be on how to reduce the consumption of natural materials into that. So with the time, because if we consider the construction culture, last 30-40 years back, we did not have that much issue. But as we at the present, the major focus in almost every aspect is how to reduce the greenhouse gases emission associated with the materials, or try to bring out sustainability in construction. So sustainability is very important factor nowadays, because sustainability is now being given in the courses. It is being included in the courses, and it is also very important for the geotechnical engineers, where they try to use the concept of sustainability and try to forward it to the students. So since we talk about geotechnical engineering, we also encounter a lot of failures, which is typically the roads failures, and then different other failures, pavements, and then sometimes liquefaction. Due to liquefaction, we see the buildings completely uh, completely dying out, and then slow failure. So these are some of the common, although there are a lot of other examples also, but only these are some of the pictures which actually shows key we actually encounter on a daily basis. And also in during rains, we usually hear this news about the landslides, and also these are all related to somehow related to geotechnical failure or slope stability failures. So geotechnical engineers have to use their knowledge of rock and soil to understand the risks associated, and once we know the associated risk, we need to put forward some solutions which can actually help to help in the infrastructure projects. We also encounter problematic soils in all throughout the world. In particularly India, we actually observe different types of soils, typically expensive soils, which are high swelling and shrinking soils, which is locally known as black cotton soil in India. And almost 20% of the land mass is actually covered with black cotton soil. Dispersive soils, which are highly susceptible to erosion, means once it comes in contact with water, it actually disperses and completely immersed into the solution. So this is also very problematic, and it is mostly found in southern parts of Karnataka. Marine soils, another very loose sediments and with very high void ratio, high compressibility. These are also near to the coastal region. Soft soil also at certain places we usually encounter, like in Kerala, some parts where this very high compressibility and the shear strength is very low, like in Kuttanadu region in Kerala, we see that the deformation happens in 1 year around 1 meter into that area. So you can imagine how much problematic this is typically. So now, obviously we have the problems and challenges are also there in problematic soil. So but then traditionally the material has evolved. Typically we try to use cement or lime, any other material which are actually very much resource consuming materials, and also associated with greenhouse gases emission. For example, if we look into the cement production, it almost it's very high, and we are the second largest producer of cement in the world. And also we see that 1 ton of cement produces almost 1 ton of carbon dioxide gases into the environment. So at present, the major focus is how we can reduce this, amount of cement into, in the construction. So one of the solution has come out is how to reuse this industrial waste to stabilize the soil or to use in the form of embankment. So it is new proposed solution, and from the last 20 years or 25 years, you see a lot of research paper has evolved where all the locally available industrial materials are being forwarded or being promoted to use it uh, in the geotechnical engineering. Now we need to also understand about the definition of sustainability. As per the United Nations definition, it is the development that meets the needs of the present without compromising the ability of future generations to meet their needs, which means that we have to use the resources in such a way that it should also be available to our future generation. It is not like because all these natural resources are limited, we cannot use it in an unlimited manner and try to increase the consumption so that it is not available to our future generations. So sustainability is we have to use it wisely, and also it should be easily available for our future generations. So this is one of the important definition by sustainability. We also define, as per the American Society of Civil Engineers, they also define sustainability is a set of environmental, economic, and social conditions, which is basically the triple bottom line. Though we know that for anything we need different pillars. So for this sustainability, we basically consider these three as the three things, that is environment, economics, and the social conditions, or you can say the people in as the three pillars of sustainability. So which means that when we have benefit to all the three, then only it will be called as sustainability. If it only profits the people and it only profits the planet, then also it is not sustainability, because it's still we are not making the profit out of it, right? So similarly, if planet and profit is there but the people are missed out, then it is also not a sustainability. So you can see that the common reason which has actually in between the people, planet and profit is basically, the definition of sustainability. So we need to focus on all the three aspects. That is very important. How we can consider sustainability in geotechnical or as a civil engineering as a whole is, we have different points into that. We have to go for sustainable systems design. For example, the green buildings, design of green buildings, introducing the use of geosynthetic and different ground improvement techniques, and the reusing the existing foundation rather than going for the new foundation. That is one way where we can, try to use this sustainable design method. Then sustainable materials, which is very much explored nowadays. You see almost most of the journal related to geotechnical and soil stabilization. You see most journal will have papers on different recycled or waste material like fly ash, bottom ash, and then so and so. And nowadays even the bioengineered materials are also being promoted. Next is sustainable energies, how we can extract the energy which is present below the ground. So geothermal energy is now getting attention in India also. It has already been used in Europe and US, where they are trying to extract the energy through the energy piles from the ground. So they are trying to use this energy because there is a difference in the temperature when during summer you see the below the ground the temperature is cold, and vice versa in the winter season. So they try to use this difference in the temperature to extract the energy in the form of energy piles. Then obviously we have the sustainable construction and maintenance technologies, where one of the ways is we can go for precast construction techniques. Then typically ground improvements which are more, less maintenance, like dynamic compaction and etc. So these are some of the sustainability considerations. And in sustainable system design, we can also think of robust design technique, in which basically we have to consider the development of low cost materials, but it should also be high quality. So we should not compromise with high quality. As per Taguchi, he has defined that it should be the robust design aims to make the product insensitive to hard to control input parameters like the noise factors, by carefully adjusting the easy to control input parameters like the design parameters. This was given by Taguchi. And we can also apply this technique into geotechnical design, where we try to design optimal design. We go for optimal design which has actually, robust against various noise factors like uncertainty in the soil parameters, and the different construction variations are there. And also by means of optimization we can always try to, make this as a more sustainable options. Then resilience and sustainable resilience concept is also sometimes, typically being used by geotechnical engineers, which actually says that resilience means something which wants to come back. Like if there is, for example, if there is any disruptive event, like if there is an earthquake happen, then it should again the whatever the original state, it should be able to come back to certain extent, although not recovered fully, but at least up to certain extent it should be able to recover. So the, the efficiency in getting a recover is basically the concept of resilience, and it refers to the capacity to mitigate against all significant all hazard risk and incidents. So this is particularly resilience. Like for example, if earthquake happened and then the there is some problem in the embankments, so it should be able to come back to its original place. Obviously sustainability is important for civil engineers, because it is uh, a lot of issues are there, like the global warming. We know this is not a fancy word, but it is the reality nowadays. Lot of places are having so many issues, and obviously the energy constraints are there, because we don't have, because it is not unlimited, it is limited, and we have to, depend on those things which are renewable forms. So that is actually, very important. Then the resources are also very limited, like metal, cement, soil, and overall the world population is also increasing very fastly. So if the population is increasing, we need more infrastructure, and obviously if more infrastructure means we need more materials, and which is actually mostly dependent on the natural materials. So likewise, if we do not think about sustainability, we will end up consuming all the natural resources, and the goal of sustainability will not be achieved. It is also very fascinating to see that the United States and the European Union consume most of the world resources because they are the developed countries, and mostly in developed countries you have well-developed industries, and that's why you have more, the resources are also mostly consumed by them.
Yeah.
And
The
then
feedback link can you pick up?
India and China,
സ്ക്രീൻഷോട്ടും എടുത്തു വിട്ടേൻ
എടുത്തിട്ടില്ലേ?
China is
ഫസ്റ്റ്
also
മീറ്റിംഗ്
catching up fast. India and China is also catching up fast because we are also in that race to become developed country, and that's why we are also just behind them. And we have so what we can do to basically make more the infrastructure construction more sustainable, because we can actually reduce the energy consumed in construction and rehabilitation, reduce the emission emitted in construction and rehabilitation, reduce consumption of natural resources, increase the service life and lower cost. So these are the four options that we can go. We can go for those techniques which consumes less energy. We use those materials which are provide less emissions, and also try to reduce the consumption of natural resources, and go for that type of design where the service life is more. So whenever we are designing, for example, roads or the foundation, it should be it should be able for a longer life, and also the cost should be minimum. So again, the people profit, and the environment or the planet, these are the triple bottom line. And in that sustainability aspect, how do the recycled materials fit in? Because recycled materials like fly ash and all, they are coming from the industries which as a byproduct basically. So those materials can be easily recycled, and that's why they are known as recycled materials, because they are typically not manufactured material. They are a part of byproducts, and they avoid the energy and emissions associated with mining. So for example, fly ash, it is easily available in the thermal power plants, or blast furnace like it is easily available in the steel industries. So they are actually the proper candidate for the sustainability aspects. And also they also reduce the use of natural resources, because they are not coming from the mining of sand and gravel or limestone. So that way they are actually very good, and the service life and are also increased, and even those materials actually has to be disposed in some way or other in the land, which also is avoided. And there the cost is also low relative to the new material which is being processed or manufactured, like for example cement and all. So that way it is very much focused on the sustainability. So recycled materials are properly used, but always we have to use safe and wise principle. It means that whatever the materials we are using should be safe and also wise. Means safe means it should not be at the cost of the people's health. So the material should be environment friendly, and also it is easily adaptable to the applied research, and the technology transfer can easily happen. So this way this recycled materials fit in. Most of my studies, I will show the results where it is actually uh, uh, using industrial waste materials. Soil stabilization, I think most of you are aware about the soil stabilization is basically uh, we are using different types of materials to add to the soil, which actually alters the properties of the existing soil, because many times we encounter problematic soils which we have already seen few slides back, and those soils are not good for construction, and hence they need some changes in the properties. We cannot remove all the soil from that place, but we have to go for certain type of addition to the materials, like typically we use cement, lime and all, right? So typically chemical and mechanical treatment are usually given. Now, one of the other important topic that we should know is the pozzolanic reaction, or you can say a pozzolanic material. It is basically a material which are basically rich in silica and which is known as siliceous material. And in the presence of calcium and water, it actually forms cementitious compound, just like CSH and CaSH, calcium silicate hydrate, calcium aluminum silicate hydrate. So typically this just like hydration of cement produces these compounds, similarly pozzolanic reaction also produces compounds. And pozzolanic materials are typically like fly ash, blast furnace slag, silica fume, all those are kaolinite, all are pozzolanic materials. They are typically cheaper, and the strength of the soil is also improves with time. Common stabilizers that we typically know is lime, cement, fly ash, GGBS, rice husk, cement kindler. But the first two, that is lime and cement, are coming from the industries after manufacturing it, and consumption of these two are actually not promoted nowadays. So industrial waste are getting increased in our country. It is a very must for, because our country is a developing country, and industrialization is a must because we need to have industries, and so as to be at par with the developing countries. And that's the result. We are going for more industries, and more industries means higher rate of industrial waste generation. And as a result, what happens? We have to obviously go for this policy, which is reduce, reuse, and recycle, because the disposal is one of the issues that typically faced by the construction industries. So we can use this industrial waste materials in the construction or geotechnical engineering. Whatever the practice that we are using is sometimes insignificant. Still, we see many industries are facing issues how to use these materials in construction, because a lot of research is required. You don't If you don't have data, the people will not get motivated to use this. So they need to have some confidence over those materials. So and uh, promoting these materials will have both environmental as well as economical benefits. And as we have already discussed this, that sustainability is basically to minimal use of resources and use of materials. And that's why most research has focused on introducing new and environmental friendly materials and the reuse of waste materials. So most of the journals you will see nowadays is actually focused on introducing new material. And so uh, some of the methods in my one of my studies, what I try to do is, we have seen that a lot of studies include the use of fly ash, or use of blast furnace slag, or silica fume, or some other metacholine or other pozzolic materials. But the thing is, they are not sufficient, because uh, if you use only fly ash, you see only class C fly ash will develop some strength, but class F fly ash is basically lacks calcium oxide content, and it is not very much suitable. So obviously we cannot compare these materials like fly ash and GGBS and directly use it in place of cement and lime. We need to modify it. And suppose if you are going for simple cement and lime, so if you want to improve the properties of fly ash with lime only or cement only, you need to add large amount of lime. So what we did is, we try to combine the industrial waste. So we thought, if some industrial waste which is rich in something, and another industrial waste which is rich in something, why don't we try to combine and see what happens, and how it actually affects the strength of the materials. So in one of the studies, I discussed about the strain development in flies and GGBS mixtures, and we have done both with lime and without lime. Fly ash is a byproduct of thermal power plants, and GGBS is usually obtained from iron and steel industries. And in these studies, actually, what we tried to mix the fly ash and GGBS. Fly ash was replaced with different percentage of GGBS in the studies, and the samples were tested for different curing periods. And then the other studies were, it was tested for strength, as well as the scanning electron microscope and mineralogical studies, they were also conducted. So you see, this is the fly ash, a scanning electron microscope of fly ash and GGBS. You see, fly ash is very cyanosphere, very in the form of spheres, whereas GGBS, it is silt size particles which are having different, it is angular in nature. And very careful to see this chemical composition of fly ash. We see the silica and alumina is relatively higher, but calcium oxide content is very less. Whereas in GGBS, it is slightly the different. In silica and alumina is relatively less, but calcium oxide is very high. And we know that all these three are required for pozzolanic reaction. You
बात
need
करके देखें जे चीजें पूछना पूछी उधर से
the we need both silica, calcium, which actually decides how the pozzolanic reaction happens in a. So this fly ash typically is a class F fly ash, and we try to see what happens. We try to. So what we did is we try to study the strength at different percentage of GGBS, and we have also studied in the presence of lime and without lime also, and very interesting results we have obtained in fly ash and GGBS. We have seen that when we add 10%, you see the improvement in the curing period with respect to curing period. Only fly ash doesn't have much effect on the strength, and GGBS improves with time, but still the strength development is very less. And when we add fly ash and GGBS different mix ratio 10%, 20%, 30%, 40%, so it improves the strength with curing period, but still it is lesser than the GGBS. So GGBS is a latent hydraulic material and it has got sill size particles, so that's why the strength may be more. But one interesting point, we see that after 28 days curing, after 28 days, we see that the fly ash GGBS mixture, means fly ash with 30% and 40% of the GGBS mixture, it shows even the better strength than fly ash and the GGBS. As you can clearly see in the graph, that when we mix, that mixture has better strength than individual fly ash particle and the individual GGBS particle. So it actually gives us an indication that this combination of materials may be quite beneficial, and that's why we have also tried to include just a small amount of lime, which is 2% of lime, and the result is very, very tremendous. You see, with lime only fly ash doesn't have, still the strength is very lacking, but in the presence of just 2% lime, you see all the strength is jumped up. So it is in the form of MPa. Now it is not in KPa, it is in the range of MPa. So that much strong strength. And with 10 days only, if 7 days only, you see very much high strength, and with further improving the curing period, it actually improves further. With 4%, 8%, we have still studied and see with the amount of lime, we still get much higher strength. In case of mix, it is still improves with time. So it is very, very strength development is very enormous when compared to pure fly ash samples. So combination is going to be very critical. So what we did is we try to observe the XRD pattern, that is X-ray diffraction pattern, which is a form of mineralogical studies. We try to identify the different minerals, and we have tried with 0%, 2% lime and 8%. Just try to see what are the minerals that is present in that material. So this is, you see, this is for the 28 days. Here we see in the 28 7 days curing, you see the large peaks of calcite, that is quartz and calcium silicate hydrate at certain point, but it is not very much easily identifiable, calcium silicate hydrate. But when we see 28 days curing period, and we see this is for the 40% GGBS, at 50 degree we see that the peak is increasing with lime. Okay, even though it is a 0% lime, we can still see the peaks. In the previous case also we have seen the peaks, but that is not the calcium silicate hydride peak. Typically that is a quartz peak, and when we add lime due to the pozzolanic reaction, it gets consumed. So quartz, which is silica SiO2, which is actually crystalline form of silica, it actually converts into less amorphous, and since calcium silicate hydrate is an amorphous form, and that's why the peaks are slightly reduced. But typically we have identified using the database that that is the CSH, calcium silicate hydrate. An interesting point is that it is even identified without the addition of lime. So that is very, very, very important. and peak intensity increases with the further addition of lime. And then the SEM images, scanning electron microscope images, we see the in the 0% lime, without lime, we see the smoother particles of fly ash, but a very dense matrix is observed when we add just 2% lime, and we further 8% lime, you see it is completely, the individual particles are not observed, and very much very the dense particles are there and the dense matrix is forms. Hydrogen products are easily visible. So the strength gain is actually justified by these microstructural studies, that with the increase in lime content or with the increase in curing period also, we see the strength is increasing. Similarly, for 28 days also, again we see that the with 28 days further similar observations are taken. Now with we have seen that this is fly ash and GGBS mixture. We have actually found out that okay, this is fly ash and GGBS is actually a good proportions, and once we find out, we try to use this as a binder to stabilize the expensive soil, and we have selected 70s to 30. Why 70s to 30? Because we have seen that 70% fly ash and 30% GGBS is having better effect than the individual fly ash and GGBS, and that's the reason we have actually proposed the 70-30 mix of that. And in the soil we considered for the stabilization purpose is black cotton soil, but what we did is we also added some commercially available bentonite, sodium bentonite, some 20%. Why we did is to enhance the the swelling characteristics, or enhance the this so that the amount of swelling is increased, and we'd like to see how the effect is there when we add this binder. So the binder is 70-30 mix, and the soil was 80% black cotton soil and 20% bentonite. And we have checked this time swell variation using oedometer test. Then we see that when the binder is increased like 10%, 20%, 30% and 40%, the swelling is also reduced. You see the percentage swell, there is a drastic reduce in just 10% binder, and further 40% binder also there is very less than 1% swelling, but still it swells. But just we add 1% lime, and you see in the right side graph that the swelling has reduced drastically, and with 10% less than 0.5, almost 5, and with 30% and 40% there is no swelling at all. So this is one important result, that if we combine it using the using this 1% lime and binder, then it is found to be more appropriate, and it is more efficient in reducing the swell. So it is a drastic reduction. Then we have checked the unconfined compressive strength studies with the binder content, and we see without lime, we see the trend that initially the strength is increased, and after a certain point like 20% binder, it is reduced. It typically happens because after reaching optimum percentage of binder, materials are tend to reduce at certain percentage, because there is a difference in the packing, and the soil matrix is disturbed. So as a result, what happens is that the strength gets reduced typically. So that's why finding out the optimum percentage of binder is also one of the important aspect, and typically considered by geotechnical engineers, because in the field we need to apply it, and how much binder we have to apply, that is decided by these tests. So the unconfined compressive strength with 1% lime, you see that it increases with 20%. After 20% it slightly decreases, but still it has better strength than 10%. So why this happens is that because the lime, presence of lime actually, whatever the disturbed matrix or the unbonded sealed particles, they are also getting bonded in the presence of lime. So that's why even a small percent of lime helps to maintain the strength of the soil composite. So this is very important results. And again we did the XRD and ACM studies, and we can easily find out the different dilated grains, very dense matrix is easily observed, calcium hydroxide. And also in the mineralogical studies, we can easily identify the calcium silicate hydrate at as the peaks, and then other peaks are also observed. So this was about the fly ash and GGBS mixture. In another studies, we have tried to understand that if we use fly ash and lime sludge basically coming from the water treatment plant, we try to combine these things and also try to use some fibers and try to see what happens to the strength. And this is one studies we have got that this fly ash and lime sludge mix after 7 days and 28 days, actually the strength is very much improved with 50 percentage showing the maximum strength. So the this is actually very good, and also we can actually change the lime content, and accordingly the gypsum content, and accordingly the strength is improved. Now what we see here is that this when we try to observe the mineralogical studies, we observe that the already the calcium silicate hydrates are formed, then other minerals as usual it is being formed, but apart from that it is calcium carboaluminate hydrate is also getting formed. This may be reason because lime sludge is basically calcium carbonate. So in the because of the presence of calcium carbonate, this calcium carboaluminate hydrate is also formed, which is also again the type of hydration compounds which actually improves the the material strength of the material or the composite. Then again some more studies with using effect of salt polypropylene fibers to check the strength and ductility, because many times when we're using as a subgrade material, we need to have a proper tensile strength. So the CVR value also got improved, and as you can see the salt polypropylene fiber, they are actually restricting the movement of the soil mass, and as a result what happens is that your tensile behavior is improved. So as you can see that it is filling the bridge, filling the gap, and acts like a bridge. So this was about the lime sludge. Next study we have actually focused.
बड़े क्या खा लिए हैं सच बोल रहे हैं
We have actually focused on using the utilization of coal mine overburden waste. If some of you are aware about Dhanbad and all nearby mining areas, you see these are the common scene that we usually encounter, and these are nothing but these are the overburden mine waste which is getting deposited. So because when we are mining for coal through open pit mines, we are also getting the rocks and other fragments or the soil, and they are actually discarded in this, and slowly what happens, it becomes a big hill, and then a lot of disaster happens because of that. So this adverse effect of coal mine waste dumps mainly include the problems with the stability of the slopes, erosion, ground and landscape disturbances, and as a result we thought of using this overburden waste to use as a subgrade material or in the construction of roads. So fly ash has been used as a filler material, and in the study we try to add fly ash to the OB waste because the main idea was to improve the packing and the bonding of the mix, and since fly ash is a porogenic material, it can also help to improve the strength behavior of the waste. So we tried with different samples. One was only with coal mine waste, then fly ash, and then coal mine waste at 10% fly ash, 20% fly ash, and 30% fly ash, different mix. And we also added a very small minimal amount, 3% of cement also. So we see that it is actually showing good response, and Mixi has actually shown better results where we have 20% in the presence of in the presence of cement. So it gives you the maximum strength and in the form of MPA. So that is more, suitable for being used. So there is some trend which we observe that due to the compaction density, UCS value is found to slightly reduce with fly ash, but addition of 3% cement led to significant increase in UCS, and uh, because of the role of ozone in the reactivity of fly ash. So fly ash can be very much useful in improving the strength. And then some more studies with stabilization of soil using bottom mass and areca fiber. So what we did is we tried to use, this is one of the work done by our MTech students, and areca is mostly available in southern parts of India and also northeastern part. Areca is that the betel nuts that we are using, no? That outside fiber is the areca fiber. And we have seen that lot of studies are there in coir fiber, but areca fiber, there were not much studies. So we try to use this as a areca fiber, and we try to, but one of the important thing is, important aspect in this is that areca fibers are basically biodegradable in nature. But one way what we can do is we can use this technique of washing and cleaning with acetic acid and sodium hydroxide. So it can actually improve the the biodegradability characteristics. So it has been proposed by the Wood Institute of India, which is in Bangalore. When we contacted them and came to know that using certain cycles of washing and cleaning with acetic acid and sodium hydroxide, it actually improves the by it makes it a little less biodegradable. So the lifespan of these fibers can be increased. So we use these fibers, and bottom mass was used as a stabilizing material. Bottom mass is basically also coming from the thermal power plants. It is less polycyclic in nature, and as a result, what we have done is we have also added a certain amount of lime as cement, 3% of cement, and we see that with the increase in fiber content, the strength is increasing, and the split tensile strength, which is basically governing the tensile behavior of the soil mass, it is also increased with the curing period. And this is this scanning electron microscope. Now, it is also very important to note that we also have basically manufactured fibers present with us, like polypropylene fiber or PVA fibers. They are all manufactured. They are little costly sometimes, like PVA fibers are costly. The main advantage of this natural fibers is that they have very rough texture, and because of their rough texture, it actually improves the bonding between the soil particles and the fiber. So it actually enhances better than the PVA or the polypropylene fibers. So as you can see, the rough structure areca fiber, and it has a very good fiber soil interface. So once we observe this areca fiber, we try to use different other fibers, and we also try to add. Uh, Initially, we had the thought key the manufactured fiber or commercially available fibers will have better strength, but we try to study this using this simple experimental setup, the model footing tank, and we used different fibers, and then we have used with the loading frame and try to load it and see the load deformation behavior. So here you see this is the graph which where we have used the sisal fiber, coir fiber, areca fiber, and the PVF fiber. And you see the PVF fibers are actually not performing better. PVF fibers are actually less value than all the three natural fibers. So this may be because the natural fibers are having better texture and rough texture, which actually improve the strength. And the treatment is basically in the treatment, if you follow the treatment, we can actually increase the biodegradability issues can be reduced, like they are rinsed with acetic acid, washed in water, and over dried, so that way we can increase it. This is another images of fibers along with the fiber soil bonding. Now another studies we try to use and as bamboo as a structural pile. So we know that bamboo is most abundant in India, and almost 14 million hectares of bamboo forest area is present. And bamboo can be promoted as a substitute for wooden steel because it is very strong material and very fast growing, because bamboo, the growth period is very, very less. Within few months you can see the bamboo growing up, and as a result this has got a very good application. And many countries, they are also trying to promote this using engineered bamboo and all. We try to use this bamboo. So we have used bamboo directly and infilled with concrete, and also we have tried to compare with RCC pile and concrete pile. So the composite pile is basically the bamboo which is infilled with concrete, and we have seen that the composite pile even is much better than the RCC pile or the concrete pile. So composite pile means containing this bamboo is actually performing much better. So this is very good results that we have obtained, and we have done with different, diameter studies. I am showing only the few results, but we have done with different, we have done the variations in the length of the pile as well as the diameter of the pile. And we have, in all the results, we have seen that the composite pile is much better. Even the bamboo pile, without, if you do not infill it with concrete, is still better than the RCC pile and concrete pile. So the strength is much better than, RCC and concrete. So it is a myth that RCC pile is always performed better. So again, in this case, the biodegradability can be the issue, but there are certain institute which give some treatment period, like in Auroville in Puducherry, they are giving some kind of, they are studying how to improve the biodegradability nature of the bamboo, and then lot of studies are also available in different journal articles. Then last we'll discuss about the bioengineering, which is basically at the present I am focusing on. Through my SIR project, we have tried to use this bioengineer technique, which is applying certain kind of microbes into the soil. So we'll discuss about this in the next slides. So before that, we should know what is microbial induced calcite precipitation, which is MICP typically, and which is nowadays very much popular because many researchers are focusing on this. It is one way in which we can avoid cement, and we can use basically bacteria, a particular type of bacteria, where we are using this to, secrete a typical particular type of enzyme. In the presence of enzyme, actually there are formation of calcium carbonate, which this calcium carbonate helps us to fill the voids, as well as they are also ready to have a good bonding. So this way, this microbial induced calcite preparation is going to be very much useful for geotechnical and civil engineers. So this is the, principle. So you have the original soil, we have some vials, but due to biocementation, the particle to particle contact is strength, and also the clogging, which is, the filling the voids with this precipitated material, which is calcium carbonate, it actually overall improves the material. So you can see the sand which was there, the UCS samples of sand is very difficult to make, but when we treat it with MICP, the sand also becomes very hard, as you can see in the right side picture, because of the, proper bonding between the particles. So this is the mechanism of MICP. And what happens is that we have a certain kind of bacteria which produces urease enzyme. That enzyme basically breaks down the urea into ammonium and ammonia, and further ammonium, and then ammonium is ammonia, and ammonia is then due to hydration it forms ammonium ions, and then this uh, this hydroxide ions are also produced, which actually, breaks down the carbonic acid into carbonates, and the calcium ions which are present in the solution in the form of calcium chloride or in the form of, calcium oxide, they react with the carbonate ions formed and forms the calcium carbonate. And this calcium carbonate, when it, because calcium carbonate is mostly neutral material, once it forms, it tries to settle down and fill the voids, or it actually coats the particle with particle to particle bond. So that way it is actually very much, useful, and only certain kind of bacteria can be used using this, like Sporosarsina pasturis, Bacillus subtilis, and some other bacteria is there. And so what we did is, in some studies we have done the MICP studies on colas and also MICP studies in the sands with biochar. So let us see one by one. In in one of the MTech projects, what we did is we have tried to use the MICP in sand clay mixture. So one thing we should also keep in mind that MICP is very much effective in sands, not in clays. Why? Because in sands we have larger voids. Due to the presence of larger voids, the bacteria can easily do their process of urease activity, and they also will be able to stay for a longer time, because in the voids you have large space available for the bacteria, and they can grow and they can secrete the urease. So that way sands are much, better place for the bacteria to survive for a longer time. But in case of clays, the voids are very less. So that's why MICP has not been found to be very much suitable in expensive soil. But still, there are many studies, even my present students, they are working on it, and they have published recent some literature. So we thought we should try to see how much clay should be there in order to see how much clay percent is actually optimal. To find out the optimal percentage of sand clay mixtures, we have done these MICP studies, and we have seen that with 90% and 10% clay mixture and untreated treated, you see both the ways. You have uh, here the big difference is there in case of 80% and 20%, but the difference is reducing, with treated and untreated when the percentage of clay is increased. So you see with 60% and a 40% clay mixture, so it gives you indication that at what percentage it will be, optimized. So further, we can say that if you go more than that, this clay percentage, then it won't be much effective, because you see the strength in both the cases are, almost similar without treatment and are treated. So that way gives an idea about that which percentage of sand and clay mixtures will require, the MICP treatment. Okay. So this is what we have discussed, and in another studies we have tried to see strength and stiffness properties of bioengineered flyers. In flyers, we have used only MICP technique to improve the properties. No lime, no cement, nothing, just the MICP technique. We have used the bacteria to pass in through the samples, and also use bacterial solution, and also the nutrient solution, because we need to survive the bacteria, and bacteria can only sustain if we supply the nutrients. So we have done the shear strength stiffness properties, and this is the experimental setup where we see that, the samples, as you can see the detailed experimental procedure, where we prepare the culture paste, and with that culture we are actually preparing the bacterial solution. And then we also check the urease activity test, because it is important, because when we are culturing, it should be in a very good environment. Otherwise what will happen, the other bacteria can also grow, which is not urease producing. So in that case, we need to check it that whatever the solution, bacterial solution is there, it actually has urease activity. And then we have prepared the cylindrical column preparations, and we put those columns with the flyers samples, and then we try to pass the microbial solution as well as nutrient solution using the peristaltic pump, and with different number of cycles we have actually got the UCS samples. And then in another case, when we tried to do the direct shear test, we had the mold, as you can see the mold prepared with the wood sticks, and then it was kept immersed in the bacterial solution for some time, and you see after some time it got hardened, and then we have used this as a direct to determine the direct shear strength. So this is some of the results where we see the compressive strength with the number of MICP treatment days, it actually improves, and the compressive strength is improved, the shear strength is increased, and also the calcium carbonate content, which was, how much calcium carbonate is precipitated, that is also correlated with that, and it is observed that it exhibits a very good good correlation between the amount of calcite present as well as in the increase in the UCS and direct shear strength test. So this is very interesting results we have seen, and we have tried to observe key what is the scanning electron microscope nature of the samples, and we have seen that the strength and stiffness properties is increased because of the formation of the bonding between the individual particles, as you can see in the ACM images, and the particle are coated with the calcium carbonate precipitated. So you can clearly see, and this is another results which shows the stiffness properties. The stiffness is also increasing, means that as we increase the treatment period, it becomes very stiff, and the it is not no more flexible, and stiffness means it is giving some kind of uh, reaching from plastic stage to elastic stage. Okay, so this is what we observed, and the strength improved from merely 23 kPa to 427 kPa. So there is a quite significant improvement in the strength of the fly ash. And remember, we are not using any lime or cement. We are just using microbial solutions into that. Now, in another study, one of my students submitted his thesis on the biochar MICP coupling effect into the sandy soil. So this was to add the biochar, because a lot of studies were there using MICP in the biochar, MICP of sandy soils. But what we did is we tried to use biochar also instead of the only soil. So biochar is basically it is a eco-friendly material which is formed from the biomass, because using very controlled environment, and they are found to be very much suitable, like energy intensive, and also like very much used in agricultural purposes, but also they are able to store carbon for a longer time. So if you keep the biochar inside the soil, it will retain the carbon for a longer time. So the conversion of biomass and biochar is actually, kind of carbon capture process. So it can be able to capture the carbon for a much longer time. And this blend of my MICP and biochar, actually, we have checked the strength of that. So this is the sand which we have used. This is the particle size distribution, and this is the bacterial solution. This is the biochar that we have studied. So the reason is why we have used biochar is that they are very porous material. As you can see those pores. So what happens if you have pores into the soil? These pores will give a proper habitat to the bacteria in a very, because it is a carbon-rich material, it gives you a very, proper habitat. So the bacteria can survive for a much longer time. So we have done without biochar also and with biochar also a different percentage. And we have observed that in the presence of biochar, the bacterial activity is much more enhanced. This is already published in very reputed journal. These are the chemicals that we have used. So this is these are the studies that we have done. Again, similar kind of setup that we have already discussed using direct shear test and unconfined compressive strength test. And we have seen that again the strength is increasing. And one interesting point is that when we improve the biochar, the strength significantly improves, with just 2% or 4% biochar. We are not talking about very large amount, but 2% and 4%, and the MICP activity is enhanced, which results in the improvement in the strength. So both in case of direct shear test or unconfined compressive strength, both the strength are actually improved. Then calcium carbonate precipitation, we have observed that as you increase the biochar content, the calcium carbonate precipitation is also enhanced. So that is also very good observations. And using microstructural analysis, we could able to trace the amount of calcium carbonate clusters which are formed on the surfaces of the sands, and the amount of through the EDS analysis along with the ACM, we have observed that the calcium content is actually increased in the presence of biochar. So as you can see here, the average UCS versus calcium carbonate, it is actually overall improvement is observed. So overall, we can say that if we have biochar present in the sandy soil mass, the biochar helps to improve the MICP activity by providing proper space, proper habitat to the bacteria, and also because bacteria love to have carbon, they love carbon products. So biochar is purely carbon, so they will be able to survive for a much longer time. So that is one of the good studies that we have done, and through the statistical analysis we have able to see how much carbon has been sequestered, and it is very important that we could able to see that 106 kg per ton of calcium carbonate can be sequestered. This is using simple, basic equations that we follow, and we can say that a good amount of carbon can be sequestered using this biochar technique. Okay, so that way it is a very indicative results, and which promotes the use of biochar rather than only using sand for construction. So overall, I'll come to end this presentation, and the some of the concluding remarks I am just briefly explaining that adopting sustainable approaches in geotechnical engineering, such as utilizing industrial byproducts, recycled aggregates, can significantly reduce carbon footprint, and also natural materials like areca, bamboo, natural fibers can be promoted for sustainable development. MSCP technique is actually an emerging technique, very evolving technique in soil improvement, and still more research is being done in this field, and we have to also try to find ways where biochar is found to be effective. So biochar MSCP infusion actually improves the soil significantly, and presently, some of my students are also working. They've already published that if we use biochar, and even not only in sandy soils, but biochar is also equally responsible for strength improvement in the expensive soil or in the clay soils also. Those results I have not shown here because they are just recently published articles, but maybe in future we'll see. So thank you very much for your kind listening, and if you have any questions, I'm ready to answer them, or later on if you would like to interact, you can contact me through this email. So thank you very much, and I'd like to hand over to the organizers to, if anyone has any questions or like to have discussions. Thank you very much for the opportunity once again.
Thank you, sir. If you have any question, please ask. Dear participants, if you have any question, please ask to sir. If you do not have any question,
Hello.
ठीक।
Okay.
Sir,
Yes, yes.
hello.
Yes, 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 please.
Sir, can this method be used for the foundation in the residential buildings?
Yes, it can be like you want to say that you want to use this as a fill material in the foundations.
Yes, sir,
Or
foundation in residential buildings. For example, some corrosive soil is there,
yes,
and
yes, it can be used because it has got, but initial some studies may be required because it depends on what is the type of soil. If it is a sandy soil, then definitely it can work very well. But if it has got some clay content, then you may have
yes,
to do some initial studies. That way, it is advisable to just have some understanding about the soil. But if it is a sandy soil, then it can definitely be used without no doubt.
okay, sir. Okay, sir. Thank you, sir.
Okay, thank you, sir.
Yeah, thank you.
If in future any problem is there, we will, our participants will try to contact you, and definitely you have shared your mail ID and phone number, so they will contact
Yeah,
you and the problem will
sure,
be
sure.
resolved. This whole
Sure,
GEC Buxar will again thanks you for your
Thank,
nice presentation and informative session, sir. Thank you, sir.
thank you very much.
Should
Thank
we end with this session?
you. Yeah, sure.
Okay, thank you, sir.
Thank you very much. Thank you.